So next we are going to discuss the concept angle between two straight lines. Already we have discussed about the equations of straight lines in three different forms. That is vector equation in parametric form, vector equation in non-parametric form, Cartesian equation for the two types. Now we are going to find the angle between two given straight lines. That is the acute angle between two given straight lines r vector equal to a vector plus s into b vector and r vector equal to c vector plus t into d vector is same as that of the angle between b vector and d vector. If you want to find the angle between two straight lines, you know that first one is the point, that is the position vector of the point. Here it is the directional vector. In the same way, c vector is the position vector of the point for this line and d vector is the directional vector for this line. So if you find the angle between the directional vector, that is going to be the angle between the two given straight lines. That only mentioned here, the angle between b vector and d vector. And the angle you are going to find is an acute angle. It is clearly mentioned. Okay. Now the formula is cos theta equal to b vector dot d vector divided by modulus of b vector modulus of d vector. This can also be rewritten as, when you bring the cos to the other side, it becomes cos inverse. So cos inverse of b vector dot d vector divided by modulus of b vector modulus of d vector, where d vector is the directional vector for the first line and d vector is the directional vector for the second line. That is the thing, you have to make a note of that. Now we are going to see certain remarks which will be helpful in solving the problems. Okay. First remark. Two given lines r vector equal to a vector plus s into b vector and r vector equal to c vector plus t into d vector are parallel. If two lines are parallel, the angle between them is 0. That's why I have mentioned theta equal to 0. That is, if theta equal to 0, then the value of cos theta is going to be 1. When you take the dot product and you take modulus, the value is equal to taking modulus for the individual vectors and multiply, then the answers will be the same. That is the meaning of modulus of b vector dot d vector equal to modulus b vector into modulus d vector. If that condition is satisfied, then we can say that the given two lines are parallel. Next, if the two lines are parallel, if and only if b vector equal to lambda times of d vector. This is one condition. Okay. In parallel also we are having other condition, that when you compare the directional vectors, one vector may be a multiple of the other vector. If such condition exists, at the time also we can say that the given two lines are parallel. And the third condition, if the two lines are perpendicular, if and only if the dot product of the directional vector is equal to 0. That is, b vector by d vector equal to 0, where b vector is the directional vector for the first line and d vector is the directional vector for the second line. When you take dot product, which will be going to be 0. If it is 0, then we can say that the given lines are perpendicular. Okay. So now I have summarized the formulas only in vector form. You know that a line may be given in a vector form or Cartesian form. If the line is given in vector form, you can make use of this information. Suppose if the line is given in Cartesian form, for that we are having separate formulas. Now I am going to state that formulas.